So let's delve into these a little bit deeper. We looked at classic sedimentary, right? These are going to be the most common, quite obvious. And we can classify the clastics based on their grain sizes. I know, big surprise there, right? You know, so is this a fine grain plastic? Is it a coarse grain plastic? How big is coarse grain? What's the fine grain? What's the intermediate grain?
Oh my gosh.
Yeah, lots of good questions to ask.
Great question.
Just not sure they're really relevant. All right, so here we go. So I'm looking at coarse grain. These have very large minerals. Typically, they're going to have gravel. All right, so perfect examples of that is breccia and the conglomerate. Now, I know we talked about this a little bit yesterday. I can't remember if I talked with you or maybe we talked about it in the fourth block. But when we look at these two images, I want you to pay special attention to the shape of the pebbles in breccia and how that compares to the shape of the pebbles in the conglomerate. How do their shapes compare? Yes, they are quadrilateral. Okay. Well, I mean, honestly, if you're looking at them very quickly, what's the main thing that sticks out?
Conglomerate is more round and breccia is more square.
Yeah, so the conglomerates are more round, the breccias are more square. Okay, guys, I want you to think about this for a minute. How do you get something to be round? You roll it. So what environments do we typically get round rocks? Don't be afraid to speak up. Oceans? Where are the oceans? No. 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 Certain places in the ocean, yes. Thank you. Okay, yes. So near the beach, places where we have tidal waters. Okay, so if we're talking about rocks on the bottom of the ocean that are in tidal regions, okay, big difference between there and the bottom of the ocean. Okay. So what does a tidal do to the stuff on the bottom of the ocean in those regions? So yeah, it kind of wears over it, or sometimes they even get rolled. They get caught up in that tide rolling, and so they keep getting rolled and basically abraded, and they become basically worn down and get this nice smooth look to them. We can also see that in moving water, especially when we think about rivers. The rivers rolling the rocks down through the riverbed, that's an example of that as well. So when we look at these two items, these actually are formed in the same type of environments. Whether it's in a tidal region or in rivers, they're being formed in the same environment. Yet they don't look the same. Why not? Say that again? No. Well, that would somewhat play a role, but it's not really the big concept here. So what would, basically, let me ask this. If by rolling the rock, we make it round, how many times would you have to roll the rock to really get it to be round? Yeah, a lot. We'll go with a lot. So what does that tell you? And of course, that would take time, right? So which one's been rolling longer? The conglomerate. So when we're in areas where we find a lot of conglomerate versus areas where we find a lot of breccia, the biggest difference that tells us that the breccia rocks have been spending less time in those environments than the conglomerates. So the conglomerate has spent more time being rolled down the riverbed or being rolled over in the tidal regions. Okay, that's an example of that. And the same thing here, breccias, less time in that environment. So it's not that they don't take as long to form, they just simply spent less time in that environment. When we look at medium grained, oh, what's going on here? Oh, that's interesting. There we go. All right, so medium grain is mostly sand and mineral particles, and typically we get sandstone out of this. So here's my question. Remember, we're talking about one of the central themes of this course is the fact that we can use rocks to basically peer into the past of Earth's environments. So let's say we're somewhere where we find a lot of sandstone. Exactly. So one of the first questions geologists start to ask is, how did all that sand get here? In what environments do we find a lot of sand? And I think Ty hit it right on the head. Usually in deserts. Okay, and then Chris, you said water. Explain that to me. All right, so yeah, we have a lot of water where it's rolling in on wave action. So we might have a lot of waves. But in this case, it really is moving water. And what other environments do we see that? Once we get a lot of sand. Oh, why do we get the sand down there? Okay. There we go. Okay, so maybe it's where there was water. Okay, so we look at this, and here's my next question to you. Suppose we found sandstone in your backyard at, let's say, 10 feet down. What does that tell you? Okay, it might have been water. Okay, so we must have had water presence. And if it's really far down, you might be able to say, well, it could have been a desert. What if you went into your neighbor's yard, we started doing this and we had a lot of sandstone like all the way across DeKalb County? Yeah, I think at that point you could probably say there's, when it's regional like that, there's a lot you could probably say. You might be able to say that there, was an ancient beach at one point. So this is just one piece of the puzzle. You can't really tell for sure. You need to go and search for other evidences. But it's just one tiny little piece. And when we look at sandstone,
it's just a box.
I find this piece to be really interesting here. So yesterday, you guys were told, basically you can have ripple marks that are locked into the sandstone, and that's exactly what we have here. And you can almost feel that sometimes if you're in the right environment, especially if you're like at a big beach, and you start walking up the beach, you can feel how hard those ripple marks are in the sand. They don't easily give way. That's an indication basically where those ripple marks are starting to go through that lithification process and starting to get fossilized. And this is just a review from yesterday, again, with these medium grain. They typically have high porosity. And again, this is like we said before, with the water evaporating, as it evaporates, those chemicals start to form on the granules, and then as those crystals get larger, they simply cement everything together.